Good morning and welcome back to 2214. So in this video, we will continue from the previous one and start to discuss graph. Okay. Like we said, for the graph, we also emphasize two things. One is the basic concept, the other is programming. Okay. So the basic concept we're talking about, there are several things. Is this directed graph? So are the edges directed? Are they weight? Are they connected? Sorry. Are they complete? And so on and so forth. And you need to make sure you understand all this concept. The connected usually means you can go from any node to any node. So here you want to be very careful, okay? When we talk about whether or not graph is connected, you need to discuss, hey, look at the graph, is it directed or undirected? If it's undirected, it's usually easier. The reason is if it's undirected, that basically means the graph, any edge are due direction. So if you can go from A to B, you can go from B to A. And then we have a good property, which basically means to decide connected, we only need to see whether or not we can start from a single node and it can reach all other nodes. So basically, if it's an undirected graph, and you can start from one node, you choose one node, and you can find a path from this node to every other node, then this graph will be connected. Why? Because if you, let's say you select from A, and you figure out if I start from A, I can go to B, C, D, E, F. These are all the nodes in the graph. Then I basically can start from any node to get to any other node. Why? If you have a path from A to B, C, D, E, F, and since it's undirected graph, you can similarly go from B, C, D, F back to A. So now if we say, hey, can you find a path from D to F? At least we can go first from D back to A. Why? If A can go to D, D can go to A because we have an undirected graph. And then we can go from A to F. So at least we know one path exists. Whether or not this will be the shortest path, that's a separate deal. But we only care about whether or not it's connected. If it's directed graph, then you do not have this property because you can go from A to B. Maybe you cannot go from B back to A because there's not necessarily you have a path, okay? And then we have different ways of representing a graph. We can have a two-dimensional matrix. In this way, you can decide if there is a link between from A to B, here will be 1, otherwise it will be 0. And of course, you want to be very careful because if you are an undirected graph, then the matrix will be having a mirror effect or symmetry along this diagonal, because if it's a unidirectional graph, then if you can go from A to B, you can go from B to A. So it will be mirror. On the contrary, if it's a directed graph, you do not have this luxury, okay? So there are a few properties we want you to pay close attention, and of course, there might be some question asking you, hey, whether or not you can go from A to B, or whether or not there's a circle in this graph from A to B to C to D, come back to A, and so on and so forth. You don't need, so basically you should be able to answer that question based on your elementary school math, okay? So we don't worry too much about that. Now let's talk about the programming part. Okay. Here we want you to basically understand the two parts. First, how can we figure out is there a direct link between the node 1 and node 2. So basically, there are a bunch of vertices or nodes and a bunch of edges among the nodes. And the first question we are going to ask is, hey, is there a direct edge between N1 and N2? So basically, if you have a matrix, then that's easy. Basically, you're looking for matrix, and of course, you're using the node 1 as an index and the node 2 as an index. We're asking, is this equals to 0? If it equals to 0, obviously there's no direct link. If it's not 0, if it's an unweighted graph, that basically means we only decide whether or not there is a link, then it's 1. If it's a weighted, it may have a different number. It may have a value of 100 or 0.7. Either way, it shows there is a link, okay? Here you want to be very careful. And we just illustrated, we said, hey, this is N1, this is N2. So remember, the two-dimensional matrix, they also start from 0. And maybe if the N1's name is A and N2's name is B, you need to find the corresponding index of node A and node B in the matrix. So be very careful what you're actually calling. And of course, we may have a different implementation. We may have a linked list. Okay, what if it's a linked list? Then we have a little bit uglier things. Okay, if we have a one-dimensional linked list implementation of the neighbors, and of course, this is N0, N1, N2, so on and so forth. And here we have a linked list to remember all the neighbors for N1. For example, if this is it, we have node N1 and it will pointing out edges to several neighbors. Now we need to first find the node N1 and then go through the linked list of its neighbors to see whether or not N2 is there. Okay, here you want to be very careful. You want to make sure you locate the right node. It is really N1, not any other node. And the second, are we talking about a directed graph or undirected graph? If it's undirected, then you can go through N1's linked list to see whether or not N2 is there, or you can go through N2's linked list and see whether or not N1 is there. They're the same. It's undirected edges. They should always have the mirror, okay? On the contrary, if it's a directed graph, you don't have the luxury. If the question is asking, hey, can we go from N1 to N2 directly? Then you need to go through N1 and see the neighbor list of N1 and see whether or not there is a pointing out edge going to N2. Okay, so this is one question. And the second question we are going to see in graph a lot is there a path? Sorry. What's going on? Why it will not? Okay. The second question we frequently seen is there a path between N1 and N2? This will be quite a bit different. Why? For this one, we're looking for a single step edge, whether or not there's an edge directly from N1 to N2. If they were talking about the path can be any long. Okay, it can go through all the way in this graph and finally reach N2. So we need to pay close attention of how do we find this path. And if you look at Zybook, they have the BFS and the DFS. The depth first or the breadth first, okay? I will shortly explain. So the BFS, so we will post another video on YouTube explaining the BFS and the DFS, and here I will shortly explain to it. So what is BFS? The BFS is basically start from one point and look at all the one hop neighbor. Okay. What do we mean by one hop? One hop means one edge. We go through one edge and we're going to reach it. After we look at all the one hop neighbor, we will look at all the two hops neighbor. and then 3 hops, so on and so forth. And we either look until we find the destination N2, or we will quit when we have gone through all the possible neighbors that we can reach. So what does that mean? So BFS is actually using an increase ring kind of search. R-I-N-G, I'm sorry, ring. So basically this is the start node. You look at all his one hop neighbor. So basically one hop, for example, if I shout, I can shout 50 meters. So let's say I can shout 50 meters. So everyone within my 50 meters ring, I can directly reach them. It's like one hop. But somebody will be 75 meters from me. So what do? I will ask my one hop neighbor to re-shout for me. Are you there? And my one hop neighbor will repeat what I just said. Are you there? Now it can reach 100 meters. That's a 2 hop neighbor. So basically a BFS is basically doing an increasing ring search. And then 3 hops and so on and so forth. It will go larger and larger. So basically we are going to search for a path further and further away from the starting point, okay? And if there is a path that we can reach, and eventually we're going to put it in. On the contrary, if there's no path we can reach to the final destination N2, then basically no matter how you reach it, you cannot. Why? Because at a certain point, I do not have any further neighbors that I can ask him or her, said, hey, can you shout again? And this guy will shout, but N2 is beyond the range of that guy. So the sound will only reach for 50 meters and N2 will not receive the signal. Under that case, it will not find a path to the final destination, okay? And what is the DFS? The DFS, instead of looking for an increasing ring, it will just select, you have a starting point. You randomly choose a one hop neighbor. And from this guy, you will randomly choose another neighbor of this guy, which will be 2 hop. From you, it will be 1 hop from this guy you choose, but it will be 2 hop from you. And then 3 hops. So basically, you're going to go as deep as possible along a selected path. And hopefully that you will get N2 along this path. And at a certain point, you're going to reach the final ending. So this will be a dead end. There'll be no other neighbors you can explore. So what do? You backtrack. Do you remember the project 2 when we do the matrix? The mouse find the cheese. That is a DFS search. It go as deep as possible until there's no place, no other place he can go. He backtrack and choose a separate branch. So from this point of view, the DFS search more like the way it is more like a stack. And the BFS search more like a queue. Okay. In the Zybook and realize it, they actually have the algorithm of BFS and the DFS. And we have located another algorithm or a short video explaining the DFS and the BFS. We will post this on the web page as well. Okay. So go back to our emphasis. So for the graph, you also need to understand the basic concept and the programming component. For the programming component, you need to understand 2 parts. Is whether or not there is a direct link between the 2 nodes. How can we determine that? And the second question is, can we locate a path between 2 nodes? And how do we achieve that if we already give you the representation of the matrix? It's either a 2-dimensional matrix or it's a 1-dimensional kind of linked list representation. So it's just a different representation, but the algorithm will be quite similar, okay? And I hope with these 2 videos about the hash and the graph, we provide you some review materials for you to prepare for the test 4. And thank you. And I will see you later. Okay, bye.